Most people think that bats are blind, but they're wrong, because bats can see as good as humans, and they also rely on echolocation. During the 18th century, an Italian scientist called Lazarus Spallanzini concluded that bats could navigate by sound, but echolocation wasn't demonstrated until 1938. Echolocation is the location of objects by reflected sound. But what does this mean? Covered of a giant cave with bat noises inside. These sound vibrations reflect on objects and come back to the source with a certain delay. This process is called echo. Someone can see how far an object is depending on how long the delay is. So, the further the object is, the longer the delay is.
But not only bats use echolocation. Other species such as birds, shrews, odontocets, and even humans use it too. The idea of sonar and radar came from echolocation.
Odontocets send very fast broadband clicks or trains in a certain direction from their nasal sacs. These clicks pass through a rounded region rich in lipids positioned inside the toothed whale's forehead called the melon. The melon focuses the sound waves acting as an acoustical lens into a beam or frequency, which then is projected forward into the water in front of the whale.
The waves produced by the odontocet reflect on objects in the water, forming an echo. These echoes are received in fat-filled cavities under the bottom jaw, which then go to the inner ear, middle ear, and hearing centers via the auditory nerve.
Bats, on the other hand, generate ultrasounds with a frequency from 14,000 to 100,000 Hz via the larynx, and emit sounds to the open mouth or very rarely the nose.
When the sound waves come back to the bat, the cartilage funnels the sound into the ear canal, reaching the eardrum, which vibrates in function to the sound waves. The vibrations are then passed on into the basilar membrane. Then the cochlea transforms these vibrations into nerve impulses.
Bats and odontocets both live in very dark places, such as caves and open waters. They needed a way to locate their prey, and since seeing wasn't reliable, they both had to evolve. But bats and odontocets are not from the same family, so why did they evolve in the same way?
In 2010, it was determined that both bats and odontocets had the same mutation in a protein called prestin, which affects the sensitivity of hearing. This is a clear example of convergent evolution. With echolocation, animals can see the size of the object, what type of animal is, and other features.